Hey everyone, welcome to week 4, Math 310. So this video is just going through assignment 6 really, which is the first one of the week, and some highlights of that and what I'm expecting for this assignment. Assignment 7 is review, so it just has some extra practice problems with digit place game, race to whatever, and these kind of problems. So I'll just mainly focus on assignment 6. So this one's called sums of consecutive integers. So we're exploring with that type of problem, adding up numbers that are in order. Is there any properties that we'll see as we explore with it? So your first problem is pretty simple. Just, add those sums up. Just use a calculator, add them up, write the answer down, and that's all you have to do, right? So tackle that, and then what you're going to do is put these values in this table. Like, for example, 1a, which is the sum of 1 plus 2 plus 3 plus 4 plus 5, ends in 5, would go here, right? So that would be whatever you got for a, put your answer there, etc., right? So you're going to, above you did 5, 6, up to 7, and then up to 8, right? A, B, C, and D. So just put those answers there and then complete the table. So for this one, like 2, you're just adding 1 plus 2, right? So you're always starting with 1 and then ending with whatever number is listed, right? And 10, 1 plus 2 plus all the way up to 10. Put that answer there, okay? And then check out your result. So you're going to have a list of numbers here, and then describe any patterns you see, right? Is there any patterns? Is there any relationship? Maybe even you can come up with a formula. For those of you, you don't have to, but if you can think of a formula that turns n into the number you get over here, that would be pretty cool. But in general, any patterns you see, list them there. That's an exploration. Really what I'm looking for is clear explanations and evidence that you investigated with this table. Okay, so lots of correct answers could be there. For number 4, then we're going to get into another method besides just adding them up with a calculator. We're calling this the algebraic method, and we're going to use this method for bigger sums. So step 1, and this one just kind of lists the steps, so I'll just walk through them. But step 1, notice you're just calling it n. So n equals the sum. So it's important to have that n equals for step 1. Okay, so you'll be doing this with other sums. So this is an example to follow when you do yours. And then notice on step 2, rewrite that sum, and then right below it, put the sum in opposite order. So my first one is 1 through 5, and my second one 5 down to 1. Okay, kind of lining it up term by term. Okay. And then we're going to use a little algebra here. That's why it's called the algebraic method. We're going to add these two equations up, right? And there's the property outlined there, but I'm just going to add term by term, right? So n plus n, right, is right there. And then 1 plus 5 is here. 2 plus 4 is here. 3 plus 3 is here, etc. Okay, so I'm adding term by term, right? And then I'm going to simplify that on both sides. So n plus n from algebra is 2n. And then all of these, notice, add to 6, right? And I have 5 of them, so right, I'm just summing all of those up that are in the parentheses. Okay, and then now 6 added to itself 5 times can be just written as 5 times 6. Finally, using algebra, divide by 2 to solve for n, right? So I divided both sides by 2 in step 6. And then I calculate that for my step 7. 5 times 6 is 30. 30 divided by 2 is 15. Okay, so there's an algebraic way to figure out, and this was way longer than just putting it into your calculator, but we'll see why this might be helpful. But in the end, the sum is 15, which we already know because we calculated it just by adding them all up. Okay, so what you want to do is practice with this method, right? So try that exact same method just with a new sum. Okay, so I'm looking for the steps here. Please show the steps clearly, just as I did on this page, right? So you can write it out. You don't have to say step 1, step 2, etc., but definitely write out the key pieces for each step. I'm looking for clear work here, not just the final answer. Okay. So practice with that one. And then here's the advantage to it. So the advantage is that you can do large sums. So now what if we wanted to add up 1 to 100, right? Now I don't really feel like putting all of that into my calculator, but I can use this same method, right? I write it, reverse it, add them up term by term. And the cool thing that happens is all of those sums are the same. They're all equal to 101. And then how many of those do I have? How many 101s are there? Well, I know how many numbers I started with because I added consecutively 1 through 100. So there's 100 numbers. So 100 added to itself that many times is 100 times 101. Finally, divide both sides by 2 and calculate. Okay, so now we see that that's actually faster than putting it all into my calculator. The sum from 1 to 100 is 50,050. Okay, so you're going to try another one with some, whoa, even larger. Okay, going all the way up to 300. So again, I'm looking for the steps. So you have an example here to follow. Use this example in number 5. Write it out in a very similar way here for your problem. And then I think that is it. There's this extra page here for some reason. Sorry about that. But there's nothing there. So just, I guess, a little scratch work at the end if you need an extra page. Anyway, so I hope that goes pretty smoothly. If you have any questions, send them my way. And I hope everything is going well. Okay, I'll talk to you later. Have a good week. Bye.